Before we start, I used to remember the days when it's 9 years back. I think one of my best friend, John, was the one. He was the guy who launched M-Check payments. So if you remember, it was long back where we had the Airtel and M-Check. So during that day, he mentioned that, so it was skeptical because we are using SMS and USD for doing transaction. And I remember I was asking him what's going to be, because is the consumers going to accept that kind of a payments? But if you see now, after say a period of 8 and 9 years, looks like the mobile is going to be the way it's going to make the payment. Simple. It's going to be like, let's take it for unified payments. Only last month I had to admit my son to the play school, and unfortunately they were not accepting the card. So I had to cut down a check, I had to rush to a bank, get a checkbook because I didn't have a checkbook with me, and cut a check out. But I think in the near future, all I could have do is that just ask for their Aadhaar number and the mobile number, and I can just instantaneously transfer the money to them. I think that's going to be the big game changer I think we're going to have in our next 6 months or going forward. Or it can be a card on delivery. So one of the most problem all the e-commerce players that we are facing is that what to do in case the end customer doesn't want to pay cash. So as Rana mentioned, India still is a look and feel market. So instead of cash on delivery, why can't it be a card on delivery, or why can't it be using the unified payments for making the payments? Or the latest technology, which is the NFC. So you can use your Apple Watch or your Samsung Netgear for making a payment. We already have credit cards where pay in your facility where you just tap it and the payment is being done. So this can be the technology, or even your mobile wallet. So the entire discussion that we also had was that how is the merchant and the mobile wallet comes into picture? Because unless the merchant accepts that particular technology, there won't be a lot of customers who are going to accept that. But I guess there's a lot of improvements that we are seeing actually in the market space. And one of the new technologies that we are interacting, one of the clients which we are interacting is that they use the mobile frequency for making the payment. So it's not NFC, just the mobile frequency which has been used and the card reader will reach that frequency and process the payment. That's one technology. Or it can be the digital wallet, or it can be our usual old-fashioned IVR system, innovation-related system. But one thing which I like to bring to your notice here is that what will be the payment innovation that's going to use, most of it is going to use your internet for doing the transaction and sending it to the central server for further processing and authorization. It can be an HTTP, it can be HTTPS call, XML, SOAP, API, whatever be it, but it's going to be using the internet. And in this entire channel, the weakest link, what I believe, is going to be your server, right? Because that's where everyone will be interested. If I am a malicious user, why should I focus on just one mobile device or a mobile wallet for hacking? Instead of, if I focus on the server side, I'll be able to get the entire customer's data. So, sure. So that's what the entire weakest link is. So in security, the security is as strong as your weakest link, right? So what I believe here is that what will be the payment innovations? Unless we secure your central server, it's going to be weak. Because like I used to, like when you do the mobile application, compliance and everything, the first question they'll ask is that, my data is very secure. I am using DUKPD technologies and specific encryption technology for encrypting the data. But I say is that, just give me the application. We can just reverse engineer it, get the specific URL or the IP address which I'm calling, and they can focus on the server, right? So that's what we're trying to showcase here in this demo on basically on how easy it was for a breach could have had occurred. Just a little small disclaimers before we start off. It's a card breach that which we had solved recently. In this demo, we are not showcasing on how we did the forensic analysis, but based on the analysis that we did, and we are showcasing on how the hacker or the malicious user had actually exploited that particular system. Some of the disclaimers, we have taken specific permission from the client for showcasing this as the demo. We have removed all the reference from the client from the image, and 95% of the functions that's available in the site has been removed, and the card details which are shown, which we'll be showing here, is basically dummy data and not the actual card number. So that's the disclaimer that we have. Now, just to give you more background on the forensic case, it was just a hotel engine e-com site which was accepting the basically the hotel bookings and reservations, and the web server was hosted in a shared hosting provider environment. And as usual, Visa, through their Common Purchase Point program, that CPP program, identified that this particular client had a breach, and we did the investigation and going forward. So we'll just start off with the demo. My colleague Kiruba will be showcasing the demo part. So we are trying to access the site. So the site, we just renamed it into DNS and we put it hotel booking. So there's an actual site called hotel booking thing, but it's not that, it's just we renamed it to hotel booking. So it's just basically a normal site which accepts your reservations, and you can make your card for making the payments and everything. Yeah. So let me put in the shoes of an actual malicious user. As a malicious user, what's the first thing which I'll do? The first thing which anyone will do, even when you do a VAPT or a malicious user, is to do a port scan. Because we should identify, okay, what are the open ports that's there in the site for me to see. So we are basically running the Nmap tool to identify what all ports has been opened up in this case. So we're just using ZenMap and just doing the scan. So here we had discovered open ports. So if you see, there's some of the interesting fact that first I'll notice is that port 3306 is opened up, which means that that particular system has an SQL system running, MySQL port, and they have DB instance running. Which is interesting to me. The second one is that we have port 21 opened up, which is the FTP port. So it gives me two perspectives when doing the port scan, is that one, they may not have a firewall in place. Two, apart from the normal ports, they have specific DB instance and an FTP instance running. So that gives me a lot of information to me. The second one, which most of the hackers will do, is that basically try to do a VS scan. So it can be any VS scan that's been there in the market. For our demo purpose, we actually will use SS for doing the vulnerability scan. So the objective here doing the VS scan is just basically identifying the low-lying fruits, right? Because which has been easy to exploit. So in this case, we're just launching the Nessus scanner, and yes, we just launched it. Now, VS scan usually takes around 1 hour, 2 hours to complete. So we're just posing the scan, and we're just showcasing the result of the scan which we've already done earlier. So if you see, they have a lot of vulnerabilities. Most of the vulnerabilities is related to OpenSSL. Then from a hacker's perspective, what I'll be interested to know is that they have a lot of PHP-related vulnerabilities. So if we can open up one of the PHP, most of the PHP vulnerabilities will allow us to upload a particular shell or a script which can be used to exploit the entire system. So PHP can be also be used to upload a malwares or those kind of stuff. But in the actual forensic scenario, the malicious user didn't use the PHP vulnerability for it. Basically, he used something else. So once I run the from a malicious user perspective, I just ran the via that port scanner. I just ran the Nessus. Now we had to do analyze because of web server. We need to analyze what kind of service calls they are making. So we basically use an HTTP live header to analyze what are the kind of requests that particular site could have made. So using a live HTTP header, which is a plugin in the Firefox for analyzing the request. So it's just coming up. Looks like we have set up our local Wi-Fi set system here and put the image, and looks like it's a little slow. The system is up? Sure. This is done. I think it's because of Nessus, it could have created issue, right? Yes. I think because we didn't stop the Nessus, and that's the reason why there was connectivity issue. Sure. So if I look the HTTP header request here, there's a lot of calls that's been made. So basically, calls to get the images and everything. What I'll be interested here is, can you just go down, Kiruba, a little bit? Will be to showcase you here. Go down, go down. I think it's getting loaded because we need to get the image being getting loaded, right? Can we go to the other tab, hotel booking tab? It should be there, right? No. It's still getting loaded. I think so what we are trying to showcase here is that because of the site, just let me just do one thing. Can you just check the system? We had taken the image and put it in the VM and created a small internal network. And because the system is not that powerful, so when we launched the Nessus scan, I guess there could have been a little crash there. So what we're trying to analyze here is that basically the live request which has been made from the hotel booking site, it basically is referring the images to a particular library called TimTump. So TimTump is basically a PHP library which will able to get image from anywhere and will be able to reposition it or resize it as per our requirement. So irrespective of what's going to be the source of the image, it will, when it goes to load into the site, it's going to load it as per our requirement. I think we do have a lot of network experts out here. We can ask. Do we do a restart? Okay, so just gives a moment. We're just restarting the image. I think, sorry for the technical glitch there. So in our most of forensic analysis, what I observed is that it's the basic security controls which was missing here. So till that system gets restarted, let me take another forensic case which we had discovered. It was basically for one of the merchant post terminals where they had a lot of retailers and they were accepting the card. So even though they had an EMV-enabled chip terminal, what the cashier used to do is that once the payment is being made, they used to swipe it in the their actual terminals. And unfortunately for them, the application was PADS compliant, but there was a specific malware which was running, which just scanned the entire system memory, analyzed what data was being swiped, took the track-to data, and then sent it out. So these days, all the forensic investigations that you have done is that just the basic security controls is missing in most of these scenarios. It's not that someone has evolved and tried to break the encryption algorithm. That you're not seeing. Just the basic controls is what missing, is what we observed. Now, sorry for the glitch. Coming back to the our scenario here, basically what they're using is a timtump library, which basically is getting the source from a different URL and adjusting it to the site. So, if you just can we go to and see what version of timtump is running? So, when we do the web application testing and everything, one of the main activity that we do is basically analyze what are the third-party libraries which has been used by the application for various functions. It can be something similar to the timtump, or it can be any other libraries can be used. And if those libraries are vulnerable, then your entire application can be vulnerable as well. So here we have the timtump version 1.19 which is running. And if you just Google it, you'll get a lot of details on how that particular version can be exploited. So here we are basically showing a small, this is basically an SS plugin on how the timtump PHP can be exploited and how the code can be uploaded. So any script kiddie can just do Google it out, will get the entire exploit code and get all the details there. So what the actual hacker has done is basically use this particular vulnerability and uploaded a particular shell script. Can you see that? Yeah. So we're just calling the timtump library, specifying the source to our external system, or in this case our host, and specifying the shell which has been uploaded. So this is the actual shell which was uploaded by the hacker into the scenario. So if you see the query string and the result, you'll get to know that they have actually, the shell has been, or the PHP has been actually been executed. Now, once we do the analysis of the source code of the timtump vulnerability, or do the Googling it out, we'll get to know that they're using a specific MD5 checksum for storing that file as a file name. So what they do is that they take the HTTP, the URL, then they'll do an MD5 checksum on that URL and do a hexa output. So in this case, what we do is that we basically have a Python script where we use the Python to create the MD5 checksum of that URL and then output it into an hexa format. So we're just calling the hash library, doing the MD5, works.php, and the output is going to be the hexa format. And we do have the value out here. So we just take this particular checksum value. Then if you do the further analysis, or if you read about the timtump vulnerability, most cases, the images of TimTump gets loaded into the cache folder in the particular server. So we access the cache folder, then we access the PHP, we specify the URL that we're going to have, and voila, we have the actual shell which is being uploaded by the hacker. The shell basically gives you the entire control of that particular server. You can run any commands that you want. So if you see, can make directory, go directory, go to directory, upload all I require is just these two information for doing a rainbow table attack for getting the actual card number out. Now, much more interesting to me here is that I have something called log._cv. Can we do it? And voila, they have actually storing the CVV2 in their database along with the hashed value. That's very simple, right? All I have to do is do a rainbow table attack and have the card number, expiry date, CVV, I can do a transaction. Now what's more interesting is that I go and see, okay, IPG. PG usually means a payment gateway, so let's exploit trying that. So from the looks of it, can you expand it? From the looks of it, looks like we have the entire request and response that's been getting stored. So if you just copy the request, can you copy the request and put into Note? So if you just copy the request, what we'll identify here is that we have the entire request message as goes in, and yes. We have the credit card number, expiry date, CVV2 getting captured. So basically what the application is doing is that whatever request they are going to make from the web server to the app server, they're just storing that entire request in their database schema. So this is an actual case scenario which we had identified. So can you do presentation? All I have to do is just then dump that specific column and manages the PCI, so the card information. Then we have the server on which the applications are running, then the network managing that. Now let's analyze the network in case of the breach. They actually had a firewall in place and an IPS. So after the breach, when we went and reviewed the firewall rule had any. Just basic. And the most important part is that they had a lot of inbound rules being mentioned, and at the last, they had this one specific rule being created, that is any. So when we talked to the administrators, he clearly mentioned that there was one time there was an issue with the server, and they just opened this rule to function. They already also had an IPS. IPS would have prevented this particular breach big time. But unfortunately, the IPS was only configured for monitoring mode, not for dropping the packets. And even funnier was that the 95% of the signatures in that IPS was not enabled. They had not enabled anything. So, end of the day, it was just two boxes which they just kept in front of their servers. And on the server side, they didn't patch up their systems. Their database was deployed on their web server itself. So that's too related. And on relating the application side, the application was not encrypting the DB credential, which was that is the connection string which was getting captured, and was storing the entire truncated PAN and CVV2 in the system. So if they had just followed the basic PCI requirements, they could have stopped the breach. So let's analyze. Even if they had not configured their firewall properly, and they have configured their servers, everything, they hardened their servers, then this breach could not happen. Because this cache folder in which the PHP, our shell script which we upload, if they had been just put some access control on that, then as a hacker or some malicious user, we could not have access to that particular folder at all and not to the script. Forget. So let's say there's no firewall, there's no hardening, but in the application layer, if they had just truncated the card number, so if the hacker could have access to the entire database, all they could have got would be just the truncated card number. So they had a database which has hashed value of the card number and truncated card number. Also they had a database where the entire request was getting stored. Please note, even if you just stored hash and truncated card number, we can easily do a rainbow table attack for getting the actual card number back. So PCI as a layered approach provides you a security to ensure that your entire infrastructure can be secure. So along with the application, server, and network, the process-related security for PCI, like the VAPT, WebAPT, or the firewall rule review, could have prevented this particular breach. So the entire thing, like what we have discussed in the entire forum, is that what would be the payment innovation that we're talking about? Like the question which we had in the panel discussion was that what security standard could you use for securing the data? My suggestion is that we can use PCI DSS for protecting your entire payment cycle. Just imagine that like most of the mobile application vendors used to come to us saying that the banks are not accepting my solution. So I used to ask is that how do you putting it across your banks? They're saying that I'm just saying that okay, I have these many security features being implemented. But if you just take the PADSS or the PCI approach and just substituted the card element there and put whatever your element, it can be your Aadhaar number, your mobile number, or whatever is your specific payment information there, you can use the entire PCI standard for protecting your payment cycle. So PCI, as all of you guys say, is that it's not just a card standard. PCI is a very good information security standard which can be used for protecting our entire payment ecosystem. Whether it's going to be unified payments, whether it's going to be your mobile wallets, virtual cards, whatever be the case, PCI as a standard has very good security controls which can be used for protecting your payment space. I think the food for thought before we break up for lunch is that the next panel discussion is on what are the security standards which can be used for securing it. I think just discuss among yourself and we can have a detailed panel discussion on what features can be used for protecting the payments. With that, I'll just thank you and thanks for attending the summit, and